Lessons over the distributive property. Before we do that, let's review our other properties. Mrs. Perez was looking at her bank account statement. She noticed that her beginning balance was $500. So she had 500 bucks. And she had added nothing to her account. Aww. What was the ending balance? So she ended up with $500. So what property did you apply? Again, what are the different properties? There's commutative. Commutative, in case you realize, you commute back and forth. Did this went back and forth? No, it stayed the same. Then you had associative. Associative is like you're associating with different numbers. Like you have different friends. Associating me, talking to different friends. Are you talking with different friends? Different stuff? No. Identity. Identity is, you look in a mirror, you see your same identity. Like you have an identity card, which is a driver license. So you view yourself again. Is this the same? I think it's identity. And the last one is inverse. Inverse is like reverse, the opposite. Did they do any opposite here? No, it came up with the same number. So it must be the identity property. So, for each term, give an example of two expressions that are equivalent and demonstrate that property. So commutative again is back and forth, like 6 plus 3. What if someone said on the other side of the classroom, 3 plus 6? Are they equivalent? They are. So what if someone said on the other side, I think the answer is 4 times 5, and another person said, it's 5 times 4. Will they be equivalent? Yes, it is. Commutative is back and forth. Associative is like this. Someone had to add different numbers or multiply different numbers, like 2 with a 6 plus a 3. Another person had to add a 2 plus 6 plus 3. What if the first person decided to add the 2 with the 6 was 8, plus 3 is 11? But the second person said, you know what, I want to add the 6 and the 3 together, which is 9, plus the 2 is 11. And this is associative. It's still going to be generating equivalent expression. Identity is like 5 times 1. And it still remains the same answer. So your identity is looking at a mirror and seeing your same identity. You see your same reflection. Nothing happened. Like 2 plus 0 is still 2. Nothing happened. Inverse is like the reverse. For example, you have the fraction 4/5. What is the reverse or the reciprocal of this? 5/4. From this, it'll equal 1 whole. What about 7? What can I add to 7, which is the reverse or the opposite of 7? Negative 7. What about 6? What can I multiply by 6 by, which is the opposite reciprocal of it? 1/6, which is 1 whole. And last but not least, we're going to learn this today. Distributive property is like distributing or sharing with others. For example, you have 2 groups of 5 plus 2 groups of 3. Is that the same as saying 2 groups of 5 plus 3? Is this the same thing? Let's see. What's 2 groups of 5? 10. What's 2 groups of 3? 6, which is 16. What about this one? If you did the grouping symbol first, 5 plus 3 is 8. 2 groups of 8 is also 16. So a distributive property is talking about the breaking down, distributing terms from the group. So 2 groups of 5, 2 groups of 3. Some of your parents, this is how I learned it when I was my generation, we had to draw arrows. So what's 2 groups of 5? What's 2 groups of 3? 2 groups of 5 is 10. 2 groups of 3 is 6. But before we talk about that in more in that way, let's use picture form. So imagine you had 2 groups of, let's start off easy, 4 and 2 groups of 3. So So we have 4. So it's saying this. You have 2 groups of 4 and 3. So here is group 1. Here is group 2. In group 1, you have 4 plus 3. In group 2, you have 4 plus 3. Is it the same thing as saying, how many 4s do you have here? 2 groups of 4. How many 3s do you have here? 2 groups of 3. So, 2 groups of 4 plus 3 is the same as saying 2 groups of 4, 2 groups of 3. And what will its value be? If you solve it this way, 4 plus 3 is 7. 2 groups of 7 is 14. If you solve it this way, 2 groups of 4 is 8. 2 groups of 3 is 6, so it equals 14. Let's reset this. Oh, I wish I knew how to reset this. Alright, so let's try our next example. I know there's a way. I don't know. I'll have to return it all back out here. I'm sure there is a way to reset it. So let me return all the algebra. Oh, by the way, these are algebra tiles, algebra pieces. So what when you have this one? Let's make it a little more algebraic using expression. You have 2 groups of x plus, let's use 3. So what happens if you have 2 groups or 2 piles of x plus 3? So here's group 1. Here's group 2. So in group 1, we have an x, and we have plus 3. In the second group, we have an x, and then we have another plus 3. What can you tell me about this? How many x's do you have? I have 2 x's. How many 1's do you have? It seems like I have 6 of them. So, how can I write this as an expression using numbers, operation, and a variable or symbol? 2x plus 6. So, this 2 groups of x plus 3 is the same as saying 2x plus 6. How do I get that? How many x's do you see here? 2 groups of x's. How many groups of 3's do you see here? 2 groups of 3. So all of these are the same. They're all generating equivalent expression. So 2 groups of x plus 3 is the same as saying 2 groups of x's plus 2 groups of 3, which is the same as saying 2 groups of x plus, and what's 2 times 3? 6. So another way to do it, if you do not like using algebra tile, is doing it this way. Distributing using arrows. So what is 2 groups of x and 2 groups of 3? 2x plus 6. Let's try another example. Doesn't erase. Goodness gracious. Alright, let me move all these out of the way. Part of the group. Alright, so let's try this one. What happens if you have 3 groups of x plus 4? How would you represent this? 3 groups of x plus 4. So here's group 1, group 2, group 3. In group 1, we have an x with 4 units. 4 1's. In group 2, we have another. Group 2 has an x with 4. And the third group has an x with 4. So what can you tell me about this? After we use our algebra tile, can you put them together? Can you simplify them by putting them together, putting like terms together? How many x's do you have? I have 3 groups of them. 3 x's. How many units 1's do we have? I see 12 of them. So 3 groups of x plus 4 is the same as saying 3x plus 12. Or another way, you could write it, you could have written it this way. There's 3 groups of x's. There are 3 groups of x's. How many 4s do you see here? 3 of them. So there's 3 groups of 4. That's another way to write it. So how can you do this without using algebra tile? Using the arrows. Distributing. What's 3 groups of x? 3x. What's 3 groups of positive 4? Positive 12. So 3 groups of 4. So let's try to do it now. Can we try to solve this without using algebra tiles? So here's another example. Notice how the multiplication by 2 was distributed or shared across the addition inside parentheses. So this is 3 plus 4. You have 2 groups of 3, 2 groups of positive 4. And what's 2 groups of 3? 6. What's 2 groups of 4? 8. 6 plus 8 is 14. So these are equivalent expression. So let's try this one example. 5x plus 4. Can you generate another expression that is equivalent to this? You may use algebra tiles if you want to. You do not have to. So if you are going to do algebra tile, in the first group you have an x, and you have 4. Even in the second group you have an x, you have 4. In the third group you have an x, you have 4. In the fourth group you have x, you have 4. In the fifth group you have x and 4. So collect the like terms. How many x's do you see? I see 5 x's. How many 1s are there? There are 20 of them. So 5 groups of x plus 4 is the same as saying 5x plus 20. What happens if you sit there and say, I do not want to draw these? Distribute using arrows. What is 5 groups of x? 5 x's. What's 5 groups of positive 4? 20. Or 5x plus 5 groups of 4. Really, I should have written like this first, and then we have gone that one. So what's 5 groups of x? 5x. What's 5 groups of 4? Which is 20. Let's try another example. Let's do 6. Let's make it a little harder. What's 6 groups of 2x plus 3? You could draw if you wanted to. Here's x, x, 3. We would have to draw 6 groups of this. Oh goodness gracious. X, x. Should I use less groups? X, x, 1, 1, 1. X, x, 1, 1, 1. X, x, 1, 1, 1. That's 5 groups. Oh goodness gracious. X, x, 1, 1, 1. So we had 6 groups of 2x plus 3. How many x's did we draw in all? I think we drew 2, 4, 6, 8, 10, 12. We drew 6 groups of 2x's. That's 12 x's. How many 1s did we draw? We drew 6 groups of 3s. So that's 18. And that is the answer. What happens if you don't want to draw algebra tiles? So let's distribute it. What is 6 groups of 2x's plus 6 groups of 3? So what's 6 groups of 2x's? 12x's. What's 6 groups of 3? 18. So what we just talked about is distributive property. Distributive property, you're distributing across the parentheses to the addition, wherever it's inside the group. So you're saying how many groups of this? And then what you do is you collect terms. Collect all the x's together or all the variables together and collect all the units together. And that is distributive property.